All right, here we go. We're going to solve logarithmic equations. And I'm going to do this by example, much the way I did the solving exponential equations. And solving logarithmic equations happens whenever the variable is in the logarithm, okay? And I'm going to call this part 1 because I want to make sure I do enough examples so everybody feels confident and comfortable. Okay, so the example that we're going to use to get started, it says log base 4 of 3x minus 5 equals minus 5. Okay? All right, now, the procedure, all important. What is the procedure? Okay, so the procedure, first things first, we want to isolate the logarithm with the exponent. No, with the variable. Good night. On one side. And I'm going to say this. This part 1, all these problems, no, quick note, these are all where you have a log on one side. And whenever you isolate the log with the variable on one side, you may have to combine with the properties of logs, so props of logs. So heads up, that might happen, okay? All right, so first thing we want to do, we want to isolate the logarithm that has the variable. Here's my variable x. Isolate this on one side. Okay, so in order to do that, okay, so sounds delicious. Add 5 to both sides. So here, plus 5, bam, plus 5. Right, that minus 5 is not a part of the argument, right? The argument is clearly in parentheses. So note, whenever you're doing these worksheets, the argument should always be in parentheses unless the whole thing is over there, okay? So there might be a little bit of confusion with some of that. All right, so that's gone, and I get log base 4 of 3x equals negative 5 plus 5 is 0, okay? Now, step two, I'm going to switch this into exponential. I'm going to switch to exponential form. All right, so switching into exponential form. What is my base? My base here is 4 raised to the 0 power equals 3x. So the base stays the same, right? And then the answer of the logarithm is now the exponent. So here's my exponent, 4 to the 0 equals 3x. And what do we know? What is 4 to the 0 power? Good, 1 equals 3x. And then it says, on our procedure here, step 3, we're going to solve the remaining equation. So you're going to solve that remaining equation. And then here, we divide by 3, The 3's cancel, and I'm left with x equals 1/3. Done and done. All right, let's take a look at another example. This one might be a little bit more difficult. We'll see. Hopefully not. We got negative 6 times log base 3 of x minus 3 equals negative 24. Cool, double cool. Great. I need to isolate the logarithm first. And this says negative 6 times that log. So let's divide both sides by negative 6. Divide that by negative 6. All right, the negative 6's are gone, and I'm left with log base 3 of x minus 3 equals negative 25 divided by negative 3. Carry the 29, 76, and it's a 4. Okay, now switch to exponential form. 3 is my base. So 3 raised to the 4th power equals x minus 3. And my 4-year-old might be the smartest alive, but he also knows what 3 to the 4th power is. Okay, he's been watching a lot of Dora lately. And now we get x minus 3 equals 81. So add 3 to both sides. So 84 equals x. And we're done. Don't have to go any further than that. So that wasn't bad. That wasn't bad at all. What are you talking about, Mr. Stevens? All right, let's try another one. Ooh, ooh, ooh. We have time for another one. We have time for at least one more, and we're going to do that one now. All right, here we have the natural log of negative 3x minus 1 minus the natural log of 7. Bless you. That was not a corona sneeze. And yes, I covered my sneeze. Equals 2. Okay, so there's subtraction going on here, and I got to combine this into one single logarithm, right? We have to isolate it to one logarithm on one side. So here, right, I have subtraction in between. So this is the subtraction division rule. So now I get the natural log of negative 3x minus 1 all over 7 equals 2. Now, what is the base of this logarithm, right? Because I have to switch it into exponential form. The base of this logarithm, right? Remember, the natural log of x is log base e of x. So my base here is e. So e to the second power, so I get e to the second power equals negative 3x minus 1 all over 7. This is going to be your first time dealing with e as a number. Treat it like a number. Treat e like a number because it's a number, okay? So e to the second power equals negative 3x minus 1 over 7. How do I solve this? If this was just like a 3 or a 10 or 9, what would you do to both sides? Got to get rid of that 7 first. So we're going to multiply by 7 over here, multiply by 7 over here. So those 7's cancel out, and I'm left with 7e squared equals negative 3x minus 1. What's your next move? Well, focus here. Don't worry about that. And don't try and get it to some decimal or anything else like that. Just leave it exact as it is, 7e squared. My focus is over here on the right side. I don't care what that looks like. I'll manipulate him later. What do I have to do to get x by itself? I have to add 1. So I'm going to add 1. Gone. Plus 1. So I'm left with 7e squared plus 1 equals negative 3x. Now, what do I have to do to get x by itself? Divide. Divide both sides by negative 3. I'm a negative 3. Boom. That's gone. And I can't necessarily leave a negative in the denominator, so I'm going to move the negative to the numerator. But when I do that, I have to move it to the entire numerator. All right, so a negative there and a negative there makes that a positive down there. So x, right, my x is equal to a negative 7e squared minus 1 all over a positive 3. And that is as far as I can take it.